Hello everyone. In this video, we are going to study about the periodic table, which is very important for ICSE 10th as well as ICSE 9th. Okay, let's start. In this chapter, what are the key concepts we have to focus? First one is what? Doberan's law of triad. Okay, next, Newland's law of octave. Third, Mendeleev's periodic law as well as table. Next, modern periodic law as well as table. And the last, we will discuss about the periodic properties like atomic size, ionization energy, electronegativity, metallic character, non-metallic character, valency, etc. See, we need to understand what is element. An element is a pure substance which is made up of same kind of atoms, like iron, carbon, oxygen. So in the 17th century, 16th century, there were only few elements were known. So there was no need of any classification. But with the time, new and new elements were discovered. So scientists tried to classify them in a systematic manner. So first attempt was given by Doberanus. He gave the law of triad. What he gave? A law of triad. So let's talk about the law of triad. Doberan's law of triad. What he did, he arranged the elements in a group of three such that atomic mass of the middle element was the average of first and third element. Okay, what he did, he made one triad, okay, in which three elements were present. Okay, let's take 1, 2, and 3. For example, you can see lithium, sodium, and potassium in order of increasing atomic mass. Lithium atomic mass is what? This is atomic mass. Atomic mass of lithium is 7, whereas potassium is 39. So if you calculate the average of first and third element, that is first plus third, atomic mass by 2, that is 7 plus 39 by 2. So once you take the average of first and third atomic masses, you will get a 46 by 2, that is approximately equal to 23. Okay, so atomic mass of middle element, okay, was the average of first and third element. Yes or no? What is Doberan's law of triad? He arranged the elements in a group of three, such that atomic mass of the middle element was the average of first and third. I hope you understood. But what happened? He could arrange only few elements in the triad. He could not arrange all the elements discovered at that time in his periodic table. That's why it was rejected. Let's see. Triad. Doberan's, a German scientist, made some groups of three elements. Okay, what is the characteristics? We can say atomic mass of second element. Atomic mass of second element of a triad are nearly equal to the arithmetic mean of the atomic masses of the other two elements. Okay, like just now explained, lithium, sodium, and potassium. Atomic mass of lithium is 7, potassium is 39. So if you take the average, 7 plus 39 by 2, you will get that 23. Yes or no? Okay, similarly another triad, calcium, strontium, barium. Atomic mass of calcium is 40, barium is 137. If you take the average of 40 plus 132 by 2, you will get 88.5, which is approximately equal to the atomic mass of strontium, 87.6. Yes or no? So actual atomic mass of strontium is 87.6, but the average we got 88.5. Okay, triad 3, chlorine, bromine, iodine. Okay, similarly here is the chlorine, bromine, iodine. In his triad, atomic mass of chlorine 35.5, iodine 137. So take the average of first and third. 35.5 plus 137 by 2, you will get 86.25, which is approximately equal to the atomic mass of middle element, bromine. Okay, actually it is 80. Yes or no? But he could arrange only few elements in his periodic table. Okay, all the elements he could not arrange. That's why his periodic table was rejected. Then Newlands came forward. He gave the law of octave. Okay, very very important. Newlands, an English chemist in 1866, gave a law of octave. Okay, that time 56 elements were discovered. So he has arranged all the elements in increasing order of their atomic masses such that every eighth element were having similar properties to that of the given first element. Is it clear? So, law of octave: if elements are arranged by increasing order of their atomic masses, property of every eighth element repeats. Okay. So, what are the characteristics? It contains the elements starting from hydrogen and thorium. Properties of every element follows that of the first element. Okay. But what happened is a periodic table. Okay. Was valid till lighter elements up to calcium only. Okay, then in his periodic table, these similar elements were arranged. That's why this periodic table also rejected. Limitations of Newland's law of octave. Similarity in properties of elements as per the law. Only 56 elements known that time were talked about. Newland's placed two elements in the same slot to fit the elements in the table. He also placed some unlike elements under the same slot. For example, cobalt and nickel are placed in the same slot and in the column of fluorine, chlorine and bromine. So now, so these similar elements were placed in a same slot. Placing of iron far away from the cobalt and nickel, which have similar properties. And what he did, he separated the similar elements also. Like iron, cobalt, and nickel, they are similar in properties, but he placed iron far away from the cobalt and nickel. Because of all these reasons, his periodic table also got rejected. Next, Newland came forward. He gave his own periodic table and periodic law. Next, we talk about the Mendeleev's periodic law. Sorry. Okay. So, Dmitry Mendeleev's Russian chemist in 1869 gave the Mendeleev periodic table. Okay. That time 63 elements were known. Okay. Mendeleev arranged elements in increasing order of their atomic masses. He tried to put the elements with similar properties in a group. Due to this, we find empty boxes in the table. See, he was the first scientist who tried to arrange the elements in horizontal rows and vertical columns like this. Horizontal rows he named as horizontal rows were called as like this. Horizontal rows were there. They were called as periods. And vertical columns like this. There were 7 horizontal rows and 9 vertical columns. Okay, so these rows were called as periods, whereas these columns were called as groups. Is it clear? Okay, he had arranged all the 63 elements known at that time in his periodic table. That is one of the merit of his periodic table. Okay, if they ask you, okay, you can see this was his periodic table. Okay, so group 1, 2, 3, 4, 5, 6, 7, 8. Okay, one more he named as zero group. Similarly, periods. Okay, 1, 2, 3, 4, 5, 6. Okay, what happened? Within the group, he had made subgroups like 1AB, 2AB, 3AB, 4AB, like that. Okay, and his basis of classification was what? Increasing order of atomic masses. So they may ask you define Mendeleev periodic law. So you should say the properties of the elements are the periodic function of their atomic masses. It means when the elements were arranged in the increasing order of atomic mass. Okay, so you can see hydrogen, lithium, beryllium, boron. Atomic mass of lithium is 6.9, beryllium 9. Like that, increasing order of atomic mass is there. Yes or no? Correct or not? So all such elements which fall in the same group are similar in properties, like hydrogen, sodium, potassium, same properties, beryllium, magnesium, calcium, same properties. Yes or no? Boron, aluminium, same properties, carbon, silicon. But again, this in his periodic table it was varied up to calcium. Okay, after that these similar elements were placed together. Okay, is it clear? You can see here calcium and zinc, there is no similarity. Okay, but they are in the same group. Okay, similarly, increasing order of atomic mass was not maintained. We'll discuss the demerits, sir. Okay, to understand this Mendeleev periodic law, you should understand he told when the elements are arranged in the increasing order of atomic masses, then it shows some kind of similarity in the properties. Okay, or we can define the law: the properties of the elements are the periodic function of their atomic masses. Is it clear? Okay, but we talk about the demerits, sir. Okay, position of isotopes, sir. He did not give the position to the isotopes. What are isotopes, sir? Isotopes are the atoms having same atomic number but different mass number. Yes or no? Like hydrogen having 3 isotopes, atomic number 1, 1, 1, mass number 1, 2, 3. As he had told that I am arranging the elements in increasing order of atomic mass, so he could have given the different position for this protium, deuterium, and tritium, but he did not give the position of isotopes. So isotopes are the atoms of same element having different atomic number but different atomic masses but same atomic number and similar chemical properties obviously. Similarly, see, properties of hydrogen is again anomalous. Like properties of hydrogen are similar to that of group 1 as well as group 7, but Mendeleev placed it in group 1 without any proper explanation. See, hydrogen can lose one electron. Atomic number of hydrogen is what? 1. So you can lose one electron, become what? H plus. Okay, like all the alkali metals like sodium, potassium. Similarly, hydrogen can gain one electron and it becomes H minus ion, just like halogens, fluorine, chlorine. But why he placed with group 1? He did not justify it. Is it clear? So you can see here the position of hydrogen. Hydrogen was placed along with the alkali metal like hydrogen, lithium, sodium, potassium. But why not with the fluorine, chlorine? Because it resembles the properties of halogens. Fluorine, chlorine, bromine, they are called as what? Halogens. Is it clear? Now merits, when you talk about the merits of Mendeleev periodic table, he generalized the study of elements then known as the study of more groups. Okay, in Mendeleev's periodic table, he left some blank spaces. These vacant spaces were left for including elements that were not discovered at that time. It means he had left some gaps for future elements, for undiscovered elements. Yes or no? Next, Mendeleev could also predict the properties of these unknown elements on the basis of properties of the elements lying adjacent to these vacant spaces. He predicted the presence of 3 elements. They were named as Ica boron, Ica aluminum, and Ica silicon. Okay, so if you see Ica boron later it was called as what? Scandium, Sc. Okay, and Ica aluminum. You see in the periodic table, okay, we have group 13 elements in the modern periodic table. Group 13, boron, aluminum. Ica is a Sanskrit word. Ica means next. So boron, aluminum, gallium is there in the group 13. So next to aluminum, what we have a gallium. So Ica aluminum is nothing but a gallium, Ga. Okay, similarly we have group 14 elements, right? Carbon, silicon, germanium. This is group 14 elements of modern periodic table. Okay, so Ica silicon is nothing but a germanium. Ica silicon. Ica silicon is what? A germanium. Ica silicon, germanium. Nothing but a germanium. Okay, Z is a semiconductor actually. Merits of Mendeleev periodic table: when novel gases were discovered later, they could be accommodated in the periodic table in the form of separate group without disturbing the position of the other elements. And he was able to correct the values of atomic masses of the elements like gold and platinum. Okay, he placed these elements going strictly by the similarities in their properties. Demerits, he could not place the elements he could not place the elements hydrogen in the appropriate position in the periodic table. Next, Mendeleev arranged elements in the ascending order of their atomic masses. There was no fixed position for the hydrogen in his periodic table, as it resembled alkali metals as well as halogens. Next, elements of higher atomic mass were placed before elements of lower atomic mass. Very important. Okay, cobalt with atomic mass of 58.93 was placed before nickel, which is 58.71. Okay, so increasing order of atomic mass was also not maintained. Okay, and the position of isotopes were found later. Okay, which failed to comply with the properties or the periodic table actually. So these are the merits you can remember. Next, we talk about the modern periodic law. Modern periodic table is based on atomic number. What do you mean by atomic number? Atomic number is nothing but the number of protons present inside the nucleus of an atom. Yes or no? So currently 118 elements have been discovered actually so far. Okay, have been discovered till today. Each of these possesses different properties. It is difficult to understand and use the properties of each element at a time. So hence attempts were made to discover ways to learn the properties of elements in the systematic order. So in the modern periodic table, we have a 18, 1 to 18. 18 groups are there. 18 groups are there. And there are 7 periods. Groups are 18 and period. Period is nothing but the horizontal rows. What is periods? How many periods are there? There are 7 periods. And it is classified into 4 blocks: S block, P block, D block and F block. We'll see. Basic concepts of modern periodic table. Most of the properties of an element depend on the number of valence electron actually. What is the region of periodicity in the modern periodic table? It is due to similarity in the electronic configuration. Okay, we'll see. Elements having the same number of valence electrons are grouped together. Thus, elements in the group have similar properties. For example, if you see group 1, okay, lithium, sodium, potassium, rubidium, cesium. Okay, if you see, I am writing just few elements. Lithium, atomic number of lithium is 3, sodium 11, potassium 19. See the electronic configuration KLN. So 2, 1, 2, 8, 1, 2, 8, 8, 1. Yes or no? So they are in the same group. Why? Because they all have same valence electron. That is one. Similarly, when we talk about a group 2, okay, group 2 elements. Okay, group I'm writing just few elements like beryllium is there, magnesium is there, calcium is there. Atomic number of Z is nothing but atomic number. It is 4, 12, next 20. Like that also few more are there, but the electronic configuration if you see KLMN. So 2, 2, 2, 8, 2, 2, 8, 2, 2. So they have the same number of valence electron. So that is the region of their periodicity. Is it clear? So thus elements in the group have similar properties. So this is a group 1, 2. They are called as S block elements. Okay, start from hydrogen, lithium, sodium, potassium, rubidium, cesium, francium. Group 2, beryllium, magnesium, calcium, strontium, barium, radium. They are what are group 2 elements. Okay, they are S block elements. Group 13 to group 18 are called as P block elements. P block elements. And they are known from their first member of their family, like a boron family, this is carbon family, nitrogen family, oxygen family, this is halogen family or fluorine family, and this is called as noble gas. This is what a noble gas. Okay, group 13, boron, aluminium, gallium, indium, thallium. Okay, so these are the main elements. Okay, group 14, carbon, silicon, germanium, tin, and lead. Okay, next, they are what? They exist for very short time actually. These are artificial elements. Okay, group 15, nitrogen, phosphorus, arsenic, antimony, bismuth. Group 16, oxygen, sulfur, selenium, tellurium, polonium. Group 17, fluorine, chlorine, bromine, iodine, astatine. Group 18, helium, neon, argon, krypton, xenon, and radon. Is it clear? So there are some tricks. I'll tell the sentence, you can note down. For remembering group 1, Hai Leena Kar Rab Se Faryad. Once again, Hai Leena. Leena is the name of a girl. Kar Rab Se Faryad means doing prayer to the God. Next, Beta Mange car scooter Baap Raji means son is asking for car and a scooter and dad is agree. Next here, group 13 na Bangan Aloo Gajar in Thali. Okay, Bangan means brinjal, aloo, gajar in thali means all are inside the carry bag. Next, for group 14 you can remember Kasi gaye Shankar Prabhu. Lord Shiva went to Kasi. For group 15 elements. Okay, what happens once in Bollywood? All the comic actors were ill. So there was a proverb like Nana Patekar Asrani Sab Bimar. Okay. For group 16, what happens? First time when tip top pin came, so there was a proverb. O style se tipo. Okay. And for group 17, you can remember Fir kal bahar ai andi. Okay, for group 18, you can remember like this. What happens in 1999, 2000, Australian cricket team came to India to play cricket. Or there was actually one series was there between Australia and India. Okay, in that series, Ajit Agarkar, who is currently the coach, not coach, he is the selector of Indian cricket team. Okay, he was out for 0 runs in consecutive 3-4 matches. You can search in the internet also. So there was a proverb like hai ne agar kar 0 run par. Okay, so like that you can remember at least S block and P block elements. Okay, up to 10 standard is very very important. Okay, these are group 3 to 12. Okay, are D block elements, and what happens after lanthanum, that is 57 to lutetium, that is 71, and after actinium, okay, that is thorium to lawrencium 103, they are placed below the periodic table as a F block elements. They are F block elements. S block, P block, this is D block, and this is F block elements. Is it clear? Okay, characteristics of modern periodic table. Periodic table elements arranged by the increasing atomic number. How they are arranged? If you see, okay, atomic number hydrogen 1, helium 2, lithium 3, beryllium 4, boron 5, carbon 6, nitrogen 7, oxygen 8, fluorine 9, neon 10, sodium 11, magnesium 12, aluminum 13, silicon 14, phosphorus 15, sulfur 16, chlorine 17, argon 18. Like that, it is arranged in the increasing order of their atomic number. Okay, periods. Horizontal rows on the periodic charts are there. There are 7 rows in the periodic table, and periods have been numbered from 1 to 7. Like first period is the shortest period. You can see here. This first period is the shortest period, contains only hydrogen and helium. Is it clear? Similarly, the second and third periods are called as short periods and contain 8 elements. Okay, period number 2 and 3. Okay, lithium, beryllium, here 2. Boron, carbon, nitrogen, oxygen, fluorine, and neon contains 8 elements. Similarly, sodium, magnesium, aluminum, silicon, phosphorus, sulfur, chlorine, and argon. They contains 6 this side and 2 this side, 8 elements. Okay, so they are called as what? Short periods. Second and third periods are called as short periods and contain 8 elements. Fourth and fifth periods are long periods and contain 18 elements. And the sixth period is very long period, contain 32 elements. Is it clear? So this is the fourth and fifth. You can remember. 1, 2, 3, 4, 5th. Okay, these are the long elements. So now contain how many? 18 elements. 4 and 5th. And 6th and 7th actually. They contains 32 elements. How it is? See, 6 and 7th. This is 18 is this side and 14 is here. 18 plus 14, 32. Similarly, 18 is this side and 14 is there. So 18 plus 14, 32 elements are there. So they are very long periods. What about the groups? Vertical columns are called as groups. There are 18 groups in the periodic table. Group 1 on the extreme left position contains alkali metals like lithium, sodium, potassium, rubidium, cesium, and francium. Similarly, group 18 on the extreme right side, okay, contains some noble gases like helium, neon, argon, krypton, xenon, and radon. Okay, inner transition elements are there like 14 elements with atomic number 58 to 71. Cerium to lutetium are called as lanthanoids. And 14 elements with atomic number 90 to 103. Thorium to lawrencium are called as actinides. You can see here. Okay, cerium to lutetium, lanthanoids, because it is after lanthanum. and thorium to lawrencium after actinium. It is what a actinoids. Is it clear? So this is all about the general information. Okay, what are Governor triad, Newton's law of octave, and Mendeleev periodic table and law, and modern periodic table and law. The next video will discuss about the periodic properties. Okay, so periodic properties like what will happen to the valence electron, what will happen to the atomic size. Here, just I will give you the this idea. Okay, valence electron across the period, what is going on? It is increasing first. Okay, left to right. Okay, how we can say, like if you see group period 2 you take, second period you take, or period 2 you take. What are the elements are there? Lithium is there, beryllium is there, boron is there, carbon, nitrogen. So atomic number you see 3, 4, 5, 6, 7. This one now. So electronic configuration 2, 1, 2, 2. Here boron 2, 3, carbon 2, 4, nitrogen 2, 5, like that. So what is happening to the valence electron? We move from left to right, it is increasing. Yes or no? And on the group it is same. Just now we discussed. Okay, group 1, group 2, it is going to be same. What about the valency? Across the period, first valency increases. Okay, then it decreases. And on the group it is constant because valency is determined by the valence electron. As in the group, valence electron is same. So valency also remains same. Okay, now we talk about the size of atoms. What happens? As we move down the group, number of cells increases. Yes or no? So atomic size increases in the group. And when we move in the period from left to right, nuclear charge increases. Because of that, atomic size decreases. So just see here, across the period we will see. Okay, what we have a boron, carbon, nitrogen. I am just taking atomic number is 5, 6, and 7. It means what? It has a electronic configuration 2, 3, 2, 4, 2, 5. Yes or no? All are having 2 cells. All are having 2 cells. But it is having 5 protons. It is having 6 protons. It is having 7 protons. Proton is present where? Inside the nucleus of the atom. Yes or no? Proton is present inside the nucleus of atom. So as the number of protons in the nucleus increases, so nuclear charge increases. Nuclear charge is a positive charge, which because of that, what happens? The size will decrease. Attractive force by the nucleus on the valence electron is more, right? When you move from left to right, so size will constrict, size decreases. But when you talk about the group like lithium, sodium, potassium, okay, rubidium. So here 2, 3, atomic number is 3. Here atomic number is 11. Here 19. Here 2, 8, 1. Here 2, 8, 8, 1. Right now. So you can see the number of cells increases when you move from top to bottom. So lithium is having only one cell. Okay, 2 cell actually. 2, 1 is there. Okay, 2, 1 is there. Now when you talk lithium, when you talk about sodium, sodium is what? 2, 8, 3. So sodium is having 3 cells. Okay, similarly potassium is having 4 cells. So number of cells increases. That's why atomic size also increases. Is it clear? So as we go down, the number of cells increases, so the size of the atom also increases. Metallic character. What is the metal? The tendency to lose electron. Metallic character is directly proportional to the atomic size. Okay, and inversely proportional to the nuclear charge. Remember one thing. It means if atomic size is more, metallic character is high. So down the group, metallic character increases, and along the period, across the period, metallic character decreases. Okay. Similarly, we talk about the electropositive character. Like same thing. Tendency to lose electron is called as electropositive nature. That is metallic nature only. Tendency to gain electron is called as electronegative nature. So no. So electropositivity. Electropositivity, it is the ability of an atom to lose electrons. Electropositivity high is to lose electrons. Electropositivity low means difficult to lose electrons. So across the period, as a move to right side of the atom, okay, it decreases and more attraction on the electron is there. Yes or no? Electropositive decreases from left to right, and down the group it increases. Okay, nature of oxides across the period, acidic nature of oxides increases from left to right, and down the group acidic nature of oxides decreases down the group. Okay, metals generally forms basic oxides. They are electropositive, and non-metals form acidic oxides and are electronegative. Try to understand. And metal react with oxygen, give you metallic oxide, yes or no? And metallic oxide react with water, give you hydroxides. That's why metallic oxides are called as basic in nature. Similarly, non-metal react with oxygen, it give you what? Non-metallic oxide. For example, if you see Okay, what I am telling you, C plus O2. C is a non-metal. Give you what? CO2. Now CO2 will react with water. It's called what? It form what? Acid. H2CO3. So that's why non-metallic oxides are what? Acidic in nature. Now if you talk about the sodium, metal, sodium react with oxygen. Give you what? Sodium oxide. And this sodium oxide react with water. It gives you what? Sodium hydroxide. NaOH. That's why metallic oxides are basic in nature. So no, because it is giving base. Next, chemical reactivity. Okay, chemical reactivity. When you talk about chemical reactivity across the period, first it decreases as it moves. Difficult to lose the more and more electrons, and then increases from left to right as it easier to gain the lesser number of electrons. Down the group, what happens as we move down the group? Okay, chemical reactivity increases for metals and increases for non-metals. Okay, we have one more concept called as ionization potential. What is ionization potential? It is defined as the amount of energy required to remove the valence shell electron. Okay, remember this ionization potential or energy. See, sodium is there, right? Now, sodium. Let's take sodium. Atomic number of sodium is 11. Electronic configuration 2, 8, 1. So it will lose one electron. It forms water. Na plus. Yes or no? So to remove the valence shell electron, we need energy that is called as ionization energy or ionization potential. Is it clear? So ionization energy, okay, is directly proportional to the nuclear charge. It means if nuclear charge is more, ionization energy is high, and it is inversely proportional to the atomic size. It means if the atomic size is more, ionization energy is less. So what will happen in that period? Okay, as we move from left to right, the nuclear charge increases, so ionization energy also increases. From where to where? From left to right. From left to right. Is it clear? And in the group, as we know that when we move from top to bottom in the group, atomic size increases, so ionization energy will decrease. From where to where? Top to bottom. From top to bottom. Is it clear? So if you see, okay, group of one element like lithium, sodium, potassium, rubidium, cesium, and francium. Which one will have highest ionization energy? Okay, lithium obviously. Lowest ionization energy? Okay, francium, because its atomic size is maximum. In the period, like when we talk about period like lithium, beryllium, boron, carbon, nitrogen, oxygen. Okay, in such elements, which one is having highest kinetic energy? Here oxygen is there. After oxygen, fluorine will also come, and minimum is there for lithium. Yes or no? So atomic increasing order of ionization energy is what? Lithium, boron, beryllium, carbon, nitrogen, oxygen, and fluorine also. We are not considering for noble gases because they are already stable here. What is the order of ionization energy? So lithium is there, okay, more than sodium, then potassium, then rubidium, then cesium, then francium. This is the order of ionization energy. Okay. Next we have is what? Electronegativity. Electronegativity. When we talk about electronegativity, it is defined as the tendency to attract the shared pair of electrons, especially in the case of covalent bond. So now, so electronegativity, okay, En we are writing sort directly proportional to the nuclear charge. It means if the nuclear charge is more, electronegativity is high, and it is inversely proportional to the atomic size. Inversely proportional to the atomic size. Okay, so what will happen in period? Move from left to right, electronegativity will increase. Okay, from where to where? From left to right. From left to right. And in a group, electronegativity will decrease. From where to where? From top to bottom. Okay, I hope you understood this chapter, periodic table or the periodic classification of elements. Please share with your friends and subscribe the channel. Thank you.